Okay, let's move on. Let's move on. Let's move on to day 4 of live interview preparation. Live on Twitch. Hold on, let me get my Chrome window. All right. So, hello. Welcome to the stream. Today's day 4 of live interview prep, live on Twitch, where I'm going to be solving some LeetCode problems, starting with some easier ones, and then hopefully doing some more difficult ones as we go. And also moving on ultimately to some of the dynamic programming problems that are in the study plan for dynamic programming. So I'll be doing that as well. And that's basically it. If we go to the contest page on Saturday at 7:30 a.m., there's bi-weekly contest 83 and weekly contest 303 at 7:30 p.m. Pacific time. So I'm planning on competing in those live on stream. So I'm going to be completely honest though, which is that the bi-weekly contest is less likely to happen. Just because I would have to wake up before 7:30 a.m. to do it. I'm gonna think a little bit about how important it is for me to compete in that. But ideally, I would do both. So I'll have those streams happening on Saturday. And then, as per usual, I have some problems that I've just now found that I wanted to take a quick look at. Starting with some easier ones. So let's jump right in. This is LeetCode 448. Given an array of nums and of n integers where nums I is guaranteed to be in the range from 1 to n, return an array of all the integers in that same range that don't appear. So let's do this one in Python. I think the first thing that we can do is we can create a set. Okay, so the follow-up down here does ask us to do it without using extra space. So I'm going to think about that, but let's just get it working real quick, because I think that I can at least get a working solution fairly easily for this one. So essentially what we want to do is we want to create a set of all the numbers 1 to n, and then we'll just iterate through the array, and for every number that we find in the input array, we'll remove it from the set. That's what we'll do. And then the answer to the question is just what's left in the set. So we could do that in Python using s equals a set of the range 1 to let's get n in its own variable real quick. So we've got n equals the length of nums, and so we can do this, and I'm fairly sure that that will give us the set that we want. Yeah, it did. So we have the set, and so now what we want to do is go through all the numbers. So let's go through n in nums, and then we just want to remove it from the set. So s dot is it delete? Oh wait, no. I can just do this, right? I can delete s of n. Okay, so that doesn't work. So I need to refresh my memory a little bit on. So lists. Where are my sets at? Here we go. Sets. Ooh, I didn't actually know that you could do set comprehensions in Python. That's a little cool, but I didn't see the answer to what I'm trying to figure out. Python remove from set. Okay. So I guess it's just set.remove. Key error? Oh, can you only remove what's in, if it's in there? So for n in nums, if n in s, we'd remove it. Is that what it is? Okay, that's interesting, because according to the description, all the numbers. Oh, I understand. So all the numbers in the input array are guaranteed to be in the range 1 to n, but there could be duplicates, and so my program was crashing because if I encountered a duplicate, I tried to remove it from the set again. So let's see if this works. It doesn't. The description doesn't say anything about what the order of the output should be. Although it might be the case that they want it to be in ascending order, but it's not clear from the description though. So what we can try though is we can just try to return a list version of S. So that produces the correct output for that test case. Let's run it on 1.1. Okay, so that's giving us correct output for the two examples. And if we submit, we're accepted. Okay. So the runtime is really good. We've got 95%. The memory leaves a little bit to be desired, our memory footprint. But I think that's where this follow-up comes in, where they actually don't want you to use a separate set. They want you to use constant extra space, which means, and I did a problem like this, like very similar to this the other day. That means that we actually are supposed to use the input array as our set. And so the input array is of length n, and so we actually have perfect amount of room in there to treat it as a set for all the numbers that exist from 1 to n. So let's think about this for a second. So we can't do this. We're not returning a list of the set anymore. But these two lines of code definitely stay the same, I think. So the index of n, let's just call it ni for the index of n. Ni is just n minus 1. So for example, if you encounter the number 1 in the list, the input list, the index of that in the nums are, okay. So I think there's a really smart way to do this. So once we have the index, what we can do is we can actually so here, let me just show you what I'm thinking. So let's say that we have this whoops, did I not copy that? Let's say that we have this as our input. So index 0 here actually corresponds to the number 1 existing in the input. Now the number 1 does exist in the input. So what I'm thinking is whenever we encounter a number in the input, right? Let's say that we encounter the number 1 at the end. So we've gone through all these, right? And we've made some updates to the array that I'm not going to do manually. We got the number 1 here. So what we actually go over here and do is we make this negative, because there's guaranteed to be no negative numbers in the input. So we can use the negativity of a number as kind of like a flag to say that that number's index, like the integer corresponded to by that number's index, is in the set. So because of that, it's possible to be iterating through this array and encounter negative numbers now. So actual n, or we call it n actual, is going to be the absolute value of n, because n could be less than 0, indicating that, yeah, as I mentioned, the index. So we get the actual number, and once we have the actual number, it's guaranteed to be in the range. So what we want to do is we want to go to the index. So n actual index is going to be n actual minus 1, and then we go back into the nums array, and we go to the index, and we want to make it negative. However, we don't just want to flip the sign, because in the case of like duplicates and stuff like that in the array, which is very possible, in the case of duplicates, we don't want to keep flipping it back from positive to negative. We want it to just be negative. So essentially, we're only going to make it negative if it's currently positive. So if this number is greater than or equal to 0, well, it can't be 0. According to the description, 0 is not possible. So if it's greater than 0, then we're going to make it negative. Times -1, right? Okay, so I think that part works. Now we have to generate a solution. So we have to get an answer. So let's make an empty array and return it, and let's fill that empty array with the answer. So what we're looking for in our answer is an array of all the integers that do not appear in nums. And so basically what we're looking for is every time we're gonna do this again. Well, we're not gonna do precisely that. I think in this case, we need to enumerate. Or no, we can just do this. For n in range 0 to n. So we'll just do like a normal iterator. Except these are the indexes. These aren't the actual numbers. If we encounter any number that's positive, that means that the index of that number, like the integer that it corresponds to, is not in the input. So if num sub I is greater than 0, then the answer includes negative. No, the answer just includes I plus 1. Okay, so when we implement it that way, we're still passing the 2 test cases that they provide. So let's try submitting again. Okay, cool. So we get accepted again. Let's submit it a few more times just to get kind of a range of our runtime and memory footprint and stuff. Okay, so it looks like this solution might run a little bit slower than just using a Python set, but importantly, the memory is better, right? So we're getting, our memory is now better than 68% of online submissions. And in addition to that, we solved the follow-up question, which is we solved the problem without using any extra space. So that's that one. That's problem 448, find all numbers disappeared in an array. We look at the solution. Okay, so this is going to be pretty similar to what we did. So using a hash map, that's going to be, that's pretty similar to what we did, except we used a set, but you get the space complexity of O of n. So you get linear space complexity, but you can actually do in-place modification of the input array, and that provides you with a space complexity of constant. So let's see how they do it. Yeah. So they do it the exact same way. If every number that they find in the input, they go to the corresponding index, and the number that's at that index, they make it negative. And then this is just the same as what we did here. So that gives you time of O of n, that gives you space of O1. But the optimal, okay, let me just look at this. I like the question, but the optimal solution is like one of those, either you get it right away or you need some hint. Yeah, approach one map can be replaced by set. We know that. And then there's also going to be a swapping solution. Instead of making the numbers negative, you can just like swap. It's like a cycle sort. When I was solving, I solved a different LeetCode a couple of days ago called first missing positive, and this problem is actually very similar. I would say that this problem, first missing positive, is kind of like the hard version of this problem that we just solved. Find all missing numbers in the array. Because what you end up doing is the solution that doesn't require cycling requires flipping numbers to be negative as like an indicator that of the presence of a specific number in a set. But then let's see, how do I get my code up? Oh, I probably solved it in a different language. Yeah. So this right here is kind of like the swapping thing. Anyway, so there's multiple ways you can do it. You can do it by making numbers negative, and you can also do it by swapping elements of the array until, and when you swap the elements of the array, you actually end up, so let's say that our input array is, one, well, let's just take this exact one again. Let's say you get this. What you're gonna end up with is like 1, 2, 3, 4. Not entirely sure what that is. That's the 5 and 6. That's the answer. 7 and 8. So as you're swapping elements of the array, you're actually moving the numbers to where they're supposed to be. So you're also you're also sorting it, which is why this is effectively doing a cycle sort. But then as you cycle sort, what you're going to end up with is whatever duplicate numbers we got in here, which are the 2s and the 3s. You're going to end up with a 2 and a 3 here. But when you're doing this last for loop to actually build the solution, you're going to be able to see that these aren't the numbers that are supposed to be here. We should have a 5 and a 6 here. And because of that, the 5 and the 6 would be the numbers that you put on your put into your answer and return. Do I want to implement it that way real quick? I don't think I do, just because I have a bunch of other stuff that I want to get to. Although implementing a cycle sort is good practice. So I don't know. I'm actually kind of conflicted about whether or not I want to implement it that way. I'll think about it. I'll leave the tab open, and let's just move on to another problem. So the next problem that I just kind of clicked into just to see was called move zeros. Given an integer array nums, move all the zeros to the end of it while maintaining the relative order of the non-zero elements. And it looks like if you look at the constraints, negative numbers are allowed. Even though these two examples here don't include that. And you have to do it in place without making a copy of the array. So this is going to be similar, I think, to what I was just talking about. This is going to be similar to doing like a cycle sort, where you're just swapping elements of the array. So if we take this input right here, and let's just throw that there for now. So we take those numbers, and I'm going to modify this test case just because negative numbers are allowed. So let's like throw a -1 here. Let's throw a -5 here. And so the expected output for this would be -5, -1, 1, 3, 12, 0, 0. So that's what you would want to get for this test case. Which we'll use. We'll use this test case when we actually get around to running our code. Oh, I had meant to, after the stream starting screen, change the vibe back to chill. So let's do that. I prefer the chill music for streaming. Okay, so we're moving the zeros to the end. So let's just start off with some code that we're probably gonna need, and then let's think about it. So we're gonna get the number of nums in the input, and then we're gonna go through them. Hold on, let me also just throw a link to the problem in the stream chat. Okay, now what do we do? So if we encounter a 0, we want to put it at the end. But there could already be zeros at the end that we previously put there. So what we actually need to do is keep track of the next index to put a 0 in, right? So let's just call it int next 0 index, and the very first one is going to be n-1. So at the very beginning of the program, the first 0 goes into the last slot. So let's think about this. So if let's just do this. Let's get the number. Should we call it x? No, we'll call it n. Let's just get the current number, and if it's 0, wait, hold on, this is wrong. It just occurred to me that this is wrong, and the reason that's wrong is because we're not sorting the non-zero elements. When I looked at this test case, I'd assumed that we're moving the zeros to the end and we're sorting the 0 elements, but what we're actually doing is we're maintaining the relative order of them all. Okay. So let me just fix this. So this is actually not right. This is supposed to be 1, -5, 3, 12. -1, 0, 0, right? Because we've got the 1, and then we skip zeros because they're being moved to the end. -5, 3, 12, -1, 0, 0. So this is actually what we would expect, not what I had before. So if the number is 0, then we're moving it to the end, right? If the number is 0, we're moving it to the end. So we're going to do something along the lines of num sub next 0 index equals n. That's what we're going to do. Or just equals 0, right? Because it is a 0. We just checked that. But the problem is the number that's there needs to slide forward. We need to slide everything forward between. So for example, we know that this is the final answer that we're looking for this input, But what would the first step look like? So the first step would look like 1, 0, -5, 3, 12, -1, 0. So we move the 0 to the end. We move so we start at index 0, right? And there's a 0 there. We move it to the end using this line of code, but then everything else needs to be shifted forward. And so thinking about the efficiency of this solution, like we could write a while loop or another for loop in here that does that just moves everything forward by 1. I kind of, so that we could write, and that might actually pass, because that would be like an n² solution, and that might pass all the test cases because it is an easy problem, and more importantly, because of the constraint that they give us here, that the maximum numbers we have is 10,000. So if you do 10,000 squared, what do you get? 100 million. And I think 100 million would be fine. So anyway, so that would probably get accepted, but let's not implement it that way. Let's just jump straight to trying to minimize the total number of operations done. And so I have an idea for this already. The idea is, instead of iterating through the array one element at a time like this, and every time we find a 0, we put it at the end and we shift everything over, I think what we want to do is, I think the first thing we do is we just see how many zeros there are. And once we see how many zeros there are, then we know how many spaces over everything needs to shift, right? You could also start off with zeros already at the end though, which means that for any zeros that are already at the end, so for any zeros already at the end, you don't need to do anything. For zeros that are closer to the end. So let's kind of think about it this way. Let's forget about the fact that other than zeros, you could have any number. Let's imagine that you can only have 1s and zeros. And I'm just gonna write it like this. So let's say you have like 0, 0, 1. So you have like a binary string. It's basically the same problem, right? You need to move the zeros to the end and you need to move the 1s forward, but obviously to make it the same problem, you have to maintain the relative order of the 1s. So these two zeros at the front would move to the end, and these two 1s would move to the front. I'm just trying to figure out, how do we figure out which 1s need to move the most? This one right here is going to need to move the most, right? Because what we're technically looking at is the number of zeros in front of it. So 1, 2, 3, 4, 5, 6, 7. So this one right here has 7 zeros in front of it, which means that it's going to move over by 7 positions, because all those zeros will go behind it, and then it will be the next thing. These two 1s will also need to move forward, but they move forward by 1 fewer 0. So how can we use that? How can we use that? So do we start at the end? We start at the end. Find a 0, we skip it. We find a 0, we skip it. Then we encounter a non-zero number. It will be replaced by a 0. But we don't want to move it forward just one. We want to move it forward as far as it needs to go, which is, because there's 7 zeros ahead of it, it's going to move forward by 7 positions. So let's say that we were iterating through this array backwards, right, from the end. We got to this 1, and let's say that we could just look up quickly how many zeros are in front of it. And I think we can do that because we can just iterate through the array forwards one time, and at each index we can store the number of zeros that we've already seen. So we're iterating backwards, and we get to this 1, and we know that there are 7 zeros in front of it. So we actually know exactly where that 1's gonna go. You know, it'll end up over here somewhere. And we know that everything else is going to be zeros after it. So what if we moved that 1 directly, we move that 1 immediately to its final location. So this one, hold on, let me make a smaller test case just so that it's easier to visualize. How's that? So, something like this. This is fine. So we have that. So then let's also create a new array, a parallel array where the indices correspond. That is the number of zeros that we've seen so far. So here we've seen 1 0. Here we've seen 0 zeros. So this is the input. Then this is the zero scene 0 count. Something like that. Hold on a sec. I fucked up my tabbing. There we go. So that's the scene 0 count. So then here we've seen 2 zeros. Oh, no, sorry. It's 1 1 2 2 3. Right? That's the answer. So we saw 1 0 here, then we keep seeing 1 0, and then we've seen 2 zeros. Okay, so we get 1 1 2 3. And so then when we're looking at this position, we know that we've seen 3 zeros up to and including this position. So then we start iterating through this array backwards. When we encounter a 0, we just skip it. We assume that we're iterating backwards, but what we're leaving behind, so basically from like index I through the end of the array, we're gonna make sure that that is correct before we move on. So we see a 0, we skip it. We see a 1. Now because we see a 1, we know that it needs to move over by the number of zeros in this array here. So we know that this 1 needs to move over here, right? So we move it over, but now this one also needs to move, right? Because we need to move. We can't override it. We need to move it out of the way. So we take this one, we move it over, we replace this one, but now this one also needs to move. And we can look down here to see how much it needs to move by. We know it only needs to move over by 1. So then we just have a loop that, okay, I think this will work. So let's start off by creating our scene 0 count. So let's create a vector of int scene 0. Also, I don't think the follow-up question here is easy difficulty. I think the n squared solution is what makes this easy, and I think the follow-up is actually of medium difficulty, but that's just my opinion. Okay, so let's make we got a vector of int of scene 0 count, and it's the exact same size. I like to call that, it's a parallel array where the indices in this array correspond to indices in this array. They just contain different information about that index. So for int I is 0, I is less than n plus I. So we're going to create our scene 0 count. So in order to create that, we need to keep track of how many zeros we've seen so far. So int number of zeros, right? Alright, it starts off at 0. And then scene 0, if num sub I is a 0, then we increase our number of zeros that we've seen. And then we put it in the array. We put it in here. Scene 0 count. Sub I equals number of zeros. So we've got that, and so that now we've produced this. And so now that we know that, we can start kind of the meat of the algorithm, which is we have to iterate through nums backwards. And so let me delete all this just to kind of start from a blank slate. So iterating backwards means we start off at n minus 1, and we go until we hit 0, and including 0, and like this. Okay, so the first thing we do, and this is a for loop. The first thing we do is we just skip this if it's a 0. If it's a 0, we're done. So there's an invariant in this loop. The invariant is something that doesn't. It's like a quality of the answer that we're building, which is just in place in nums. That stays the same after each iteration of the loop. It doesn't vary. So the invariant is that nums sub I through n is finished. So every time we move one step closer to the beginning, everything that we've already done, everything we've already looked at, the rest of the array is finished. That's what we're doing. So that's the invariant. So because we have that invariant, we can do this. So that's an invariant that we're gonna have to uphold ourselves, but because I'm planning to uphold it, I can then do if num sub I is a 0, we can continue. We don't need to do anything here. Otherwise, num sub I is a number that needs to be moved. So let's do this real quick. Int n equals nums I. So if n is 0, then we continue because we're good. If n is not 0, then n needs to move maybe. N needs to move maybe, and there's a case where n doesn't need to move, right? And that's if there's no zeros in front of it. So also, if the number of zeros we've seen so far is 0, so if scene 0 count sub I, if that's 0, the algorithm is actually finished because we've iterated from the back of the array and we've been moving towards the front, and we get to a place in the front where there's no more zeros ahead of us, and so we can actually just stop. Yeah, I think I want to reorder those two lines, although I don't think it affects the behavior of the program at all. That's just for me. If I'm gonna have a case that breaks out of the loop, I like to just check it first. And in this case, it's just the same. Let's also do this. let's reuse our n zeros integer. N zeros equals the equals this. We'll just put that in a variable as well. So we'll put that there, and then we'll check n zeros here. And just so that it's not confusing, let me just call this x. So we got our scene zero count. That's the number of zeros ahead of us, including the current position. If there's none, then we're done. Also, if the current number that we're looking at is a 0, then we're done here, but we do need to keep looking for the rest. Okay, now this is the juicy part, because I'm pretty sure we need a while loop here. So we know that the current number is not a 0. And the other thing that we know is exactly how far it needs to move. And we know that because we know how many zeros are in front of it in the input. It's n zeros right here. So effectively what we want to do is we want to do num sub I minus the number of zeros in front of I equals I equals x. That's what we want to do. However, we can't do that just blindly because we're going to overwrite the value that we already have up here. So I think the first thing we need to do is store that number int temp equals nums sub I minus the number of zeros, and then we can update that. But now the thing is, now we're holding on to this number from the input temp, and we now need to put that in its final position as well, which is where the while loop comes in. We're gonna have a while here, and we got to figure out what we do here. So while how long does this while loop run? We need to figure out the termination condition for the while loop, which is basically when we've moved so many numbers around that we can stop. So let's just change these so that we're not thinking in binary terms anymore. What we're expecting to see here once we're done is 24000. So what's going to happen is we're going to take the 4. We're going to see that it needs to move forward by 2 positions. So it needs to go to where the 2 is. So then this is why we have the while loop. Then we have a 2. And we'll see that it needs to move forward 1 position. So it'll come here. And so then we're done because whatever is there can't move forward anymore. So if we get to the point where I minus n zeros is 0, then we're done. Or it's also possible that we get to the point where let me visualize the problem a slightly different way. Let's have a 1 here, which means it would look like this. And the answer would look like that. So the 4 would have to move here. The 2 would have to move here. So what I'm trying to figure out is once we move the 2 here, how do we know we're done? Okay, I'm onto something. So basically, as soon as we put the last number that's not already, you know, at the front, and we replace a 0, then we're done. Because that's the order this is gonna happen. Let's say that this is like 0 0 1 0 0 3 0 whatever. So the 3 is gonna come all the way up to we're gonna end up with 1 2 4 1 3 and a bunch of zeros. Does that look right? Is that the right number of zeros? No idea. So the 3 is gonna come up. Oh yeah, and num sub I here is gonna become 0 too. So the 3 is gonna come all the way up to here. Then the 4, because there's a 2, the 4 knows that it needs to come up here. But okay, so this is where it's interesting. So the 3 pushes the 4 to where the 2 is, then the 2 moves up. But then the 1 actually hasn't moved yet. So once our first while loop finishes, we'll come through again. We'll skip all the zeros. We'll get to the 1, and we'll see that it needs to move up. So it's 1 1 2 2 2 2 2 2. Then it's 2 3 4 5 5 6 7 7 8 9. Okay, that's actually perfect. Okay, so this one would need to move forward 9. This one would need to move forward. If there was a number here, but there's not. So we know the 3 needs to move forward by 7 places, which is going to put it over here. Let's just count. So 1, 2, 3, 4, 5, 6, 7. Yeah. So it would move forward by 7 places, and it would take the spot of the 4. Then we look down here, and we see that the 4 needs to move forward 2 places. So we move it forward 2, and it moves here, and then it has to push the 2 forward. The 2 needs to move forward by 1 place, so we'll put it there, right? And then, how do we know we're done? Is it because it's because there's a 0 at that location? Yeah. So is this it right here? Is it while nums I minus n zeros is not equal to 0? We get the temp number, we update it. So I think what we need here is like a new we need another variable to keep track of our current position. So the first position we're going to be looking at is going to be I minus the number of zeros. Let's do this. Let's have a from. Int from equals I. Int 2 equals I minus n zeros. So we have a number saying where the number is coming from. We have another integer saying where the number is moving to. And then the while the position that we're moving to. Oh, is this might be better as a do while loop, right? Because if it is 0, we still want to do the last iteration. Yo, what's up, IzzyDevX? How you doing? Welcome to the stream. I'm grinding out some leak code right now. This is my second problem of the day. And I actually disagree with the flag that they gave it here. I think the follow-up question turns it into a medium problem. They've got it marked as easy. Oh, that's great. That's great. Discord is actually a company that that I've had interest in working for a while. I think Discord is a great company. Um, I know. I actually know someone with this username. You probably know who that is. I think he's either a manager or a director over at Discord. Um, but that's sweet. That's sweet that you've been a software engineer for 14 years and you're a lead at Discord. What team do you lead? And thanks for coming in. Thanks for introducing yourself. Always good to have new people hopping in. So this is interesting. I want to work for Discord. So I quit my job at Google like a month and a half to 2 months ago, mostly because I wanted to explore some personal things and have more time for non-work related activities in life. And thankfully, because I was working at Google, I had some money saved up that enabled me to be unemployed for a bit. Now I am back on the job grind to get back into like a full-time position, and I I was talking to Discord Recruiting, um, and I had a call with an engineering manager on the engineering manager of the messaging and console gaming teams. I had a phone screen with her. I don't know if I exactly recall what her name was. I'm looking at my calendar so I can try to remind myself. But yeah, they passed me up. They passed me up. It was disappointing. Like I said, I think it would be really cool to work at Discord, but for whatever reason, I had the phone screen with the engineering manager for those teams, and they ended up coming back with no. So I'm still on the grind for a job hunt. I mean, if there's anything you can do about that, I would be very appreciative. Like if you wanted to take it upon yourself to reach out and be like, "Hey, give this guy another shot," I would not. I would love you for that. But again, like I said, they had their reasons for passing me up, and I'm not sure what those were. And so as of right now, I'm still on the grind for a new job. Um, Hold on, let's see. When was that interview? Oh, here it is. Fang Hao Chen was the engineering manager that I spoke to, and that was on June 29th. Um, but yeah. So that's just to be completely transparent. That's what happened with that. It would be really cool to work for Discord though, and if there was a way I could get them to reconsider, I would definitely try to do that. But either way, thanks for hopping in, and yeah, right now I'm just, as you can see, I'm grinding out some leak code. So, where was I at with this? So I've got my variable that I'm moving the number from, and I've got my variable that I'm moving the number to, and oh, I see. Yeah, all good, all good. I don't think that my skills and experience really make me like suitable for a data science role either. I was more interested in I feel more equipped to do something on the front end side, or full stack. Um, so, but as just as a follow up question, so data science, software engineering lead, what so what are you guys working on right now? Like anything that's obviously not confidential. What are the big priorities for the data science team at Discord? I'm sure you guys have a lot of stuff going on, a lot of different possible ways that you could go. Okay, So now I have my from and my to. I can take the temporary number is going to be where I'm moving to. And then I update that index to be X. Got it. Got it. So here's a question. Like, if you get passed up by a team, that automatically disqualifies you from like any other team, or is there a way that I can get in touch with other managers of other teams and have a phone screen with them? Do you know anything about that? Because you know, even if the Fang Hao doesn't think I would be a good fit, well, not just Fang Hao, but Fang Hao and team, they decided that I wouldn't be a good fit for their team. Maybe there's another team that that I would be suitable for, and if that was the case, I would definitely be interested in talking to whoever the manager of that team is. There's also no hard feelings, by the way. No hard feelings at all. Like, they've got to make the decision with the information they have that's going to be best for their team. And I don't have any hard feelings at all that they passed me up. It was disappointing, but I understand that professionally they need to do what they deem is best for them. At the moment, we are really focusing on user improvements. Like, we upgraded bots to have a badge to say they support slash commands. Nice. I think I might have noticed that one come through. That's dope. And improving stuff like autocomplete slash commands, etc. Sweet. Yeah, the bot space is another really interesting space that I like, that Discord obviously invests a lot in. Like, I'm in a couple of Discord guilds where we have a custom bot that I wrote. It doesn't do anything super fancy right now. I have plans for it. I just kind of I have other things going on as well, but I will say that just from my small amount of experience, like with the bot API that Discord offers, it's just so easy. It's like the DevX for bots, for Discord bots, is really good. Like, huge shout out to all the people who are making the DevX for Discord bots. So excellent. Not sure on that. For my lead of team, I have someone above me that does hires. Well, if you wanted to throw them my name and, you could tell them what happened, there's no point hiding that. I'd be interested in being considered for other opportunities as well. But in the meantime, I obviously got to keep grinding it out and look for other opportunities as well. Okay, let me get back to this. So we're moving that into the temp, and we're updating the to be X. Then the other thing is that we can update the from to be a 0. And I think I had discovered this earlier, but this does need to be a do while loop, I'm pretty sure. That'd be great. Yeah, let me whisper it to you. I'm probably gonna have to open up Twitch on the web to do that. Right now I just have open the like the OBS chat screen, but let me open up my stream. Yeah, for sure. No harm in trying. No harm whatsoever. So as far as your you being hopping around Twitch right now, do you stream as well, or do you just like to hop around to some of the software development channels? I assume you just came across me on the browse page for software and game development. Okay, I just whispered you that. I've been wanting to start streaming for a long time. Like, for a while, I just imagined myself being a gaming streamer, but it's very competitive. like I spent some time in the last month streaming Minecraft and streaming New World, and getting like maybe 1 or 2 viewers like per stream. Maybe if I'm lucky, like 1 or 2 people actually chatting, which is better than 0. But then when I started doing these coding streams, more people have been coming in. So that's an indicator to me that I should keep working on the coding stream. Like, I'm definitely not gonna stop streaming games, but I'm definitely gonna be focused on the coding stream, just because it seems like people are more interested in watching me doing that, and it's probably easier for people to find me just because the category is not as big yet. It's not as competitive. So yeah, we really look for users that interact with our API quite a lot. We love users that have, say, verified bots. That makes sense. Or we have seen help around, or we have seen help around in the Discord development server. Makes sense. Yeah, my bot's nowhere near the point where I would actually try to get other guilds to bring it in and you know, try to get verified. But that would be cool if I created a bot that did something fun enough. Like, my idea, I wanted to create a bot that did, like, you know, Wordle. I wanted to create like a Discord bot that would have some kind of daily like word challenge that people in the Discord could compete over. And then, you know, that kind of bot seems more appropriate to, you know, try to encourage, you know, any guild that wants to bring it in. But that was just an idea. I haven't built that yet, so I will show you something I built in case you want to brag to your engineering manager. So I built this game. This is it's kind of like a Wordle clone, but it's actually it's called Xerdle, and the big difference is that instead of the word being 5 letters long every day, the daily word that you get is any number of letters long. So it could be extraterrestrial. It could be, you know, contiguous. So what happens is once you put your guess in, you get feedback, and you get the same feedback that Wordle gives you, but you get a little bit more too. So if you get a tile that's green, obviously means that it's absolutely correct. Also, I haven't solved this one yet, so I don't know what the answer is. But if you get a star, that means there's multiple C's in the answer. Contiguous is not usually the word that I would have started with though, so I would have gone with something like corianders. And so with corianders, you can see that the yellow letters show you that letter is in the word, but you get a little arrow too, which shows you that it shows you the direction the letter needs to move in to, you know, ultimately end up in the right spot. Just a tip with bots that handle lots of buttons or interactions like Wordle, do our best to use a custom interactions endpoint. Okay. Yeah, I'm not familiar with custom interactions endpoints. I'll have to check that out. Right now I just have a bot. It's like a JavaScript bot using discord.js, and it's running in I have it running in Amazon Elastic Container Service. And it doesn't do very much, but it does have CI/CD. So the nice thing is, anytime I want to add like an extra command, you know, for the people in my friends guild to use, I can just open it up in code, commit, push, and then it goes through code pipeline and code build within AWS, and then it automatically updates the container to run the new version. One of the things that it does that I actually was pretty proud of, because it was tricky to figure out, was it integrates with our Minecraft server. So anytime someone logs into or logs out of the server, we have a channel in our friends guild where the bot will post that as like an update, so that you can kind of see who's online. You can decide if you want to log in based on if other people are logged in and stuff like that. So just to try to finish this up, so we know that the C and the N are in the right place. We know there's another C, so this might be like CAN. Okay, so this might be cancel actually. Okay, so I did solve my own puzzle in 3 guesses, which I'm proud about. And then similar to the actual Wordle, you know, it does have the share button, so I could like copy this and paste it over here. Oh, it doesn't look great in Twitch chat because they remove new lines. But if you had pasted that in like a text message, like, you know, Discord or Twitter or something, that would have looked right. but it looks like Twitch chat just strips out new line characters. So yeah, I built that, and so I wanted to try to find a way to incorporate word games into Discord bots. It just let me see what you said. It allows your bot to receive interactions via HTTP posts rather than over the gateway with a bot user. Okay, so it's like, is it like a webhook kind of idea? So whenever a user runs a slash command, it automatically calls your API endpoint. That's cool though. That makes sense, I guess. I always wondered how like bots that get used a lot, you know, for example, like the Meeseeks bot or the whatever, any of the like the really big bots that are used in hundreds and thousands of guilds. Like, how do they keep up with the traffic? I saw something in the docs about sharding, so I assume that's a part of it, and maybe another part of it is by using the custom interactions endpoint. Okay, so we've got do all of that while, not while that, while the num that we're moving to is not equal to 0. So are you jumping through the software and game development Twitch category looking for people who are coding and trying to create a referral within Discord? Because that's actually a smart idea. I imagine Discord has like a referral bonus or something that you get if one of your referrals gets hired. So trying to take advantage of that and looking for people on Twitch that are coding is not a bad idea. So if that's what you're doing, I totally get that. Okay, so we've got this might work. This might be right. Let's should I run this and see what we get? So it would be return nums. Run code. Oh, okay. Oh, I see. So this is where the in place constraint comes in. They actually don't want you to return anything. They just want you to modify the reference that gets passed in. Okay, we need some kind of base case then to exit this loop. Oh. So after we do this move, to becomes from, and from becomes, oh, we need another temporary variable for this. Int temp2 equals 2. 2 becomes from, and from becomes temp2 minus the number of scene zeros, so we get our scene 0 count. Okay, this is not quite right, and actually I think that I might need to kind of, as an example, if you have a complete case with a button, oh, interesting. And so I'm assuming that the context of this chunk of code is like a Discord JS bot. Okay. Is this you right here, River 198? Hold on, is it okay if I just like live stalk you right now? Oh, cool. Your personal website is a command line. Hold on, I'll take a look at that in a sec. How do I get to your, okay, how do I get to your GitHub profile? You're Izzy, aka Ayu. Cool, well, I'll throw you a follow on GitHub. And then let's see. So did you code this command line from scratch, or is this are you using any libraries for this? Like a specific like command line simulation library? About, banner, Bing, CD, date, donate, DuckDuckGo. Rust and WebAssembly. Oh, okay. So you compiled Rust to WebAssembly to run this on the web. You're not even using like JavaScript. I've never done anything like that. Like I know vaguely that that's possible. That's something you can do, but I've never messed with that. Nice. Well, this is really cool. What's in the README? Where can I CD to? Oh, you can't CD anywhere yet. Oh, okay. ls bunch of fake directories, CD. Okay, they're fake directories, so you can't CD into them, I guess. Oh, and the autocomplete works. So if I type G or GO, it knows that it's Google. Who am I? I'm a visitor. VI? Are you serious? Yo, you finally got to VS Code. That's great. Oh, it's just code, right? Okay. That's awesome. So you have a sense of humor. That's cool. Nice. That's awesome. That's way more exciting than my personal website. I'll give you that. I was doing some tech vlogging for a while. I've been taking a break from it, but my homepage is just you know, a index of the blog posts that I wrote. The most recent one being in 2019, so quite a bit ago. I much prefer your don't do sudo. What happens if I do sudo? Sudo su. Oh my god. You really want, that's awesome. Sudo's not on the list. Oh no, it is on the list. What happens if I... Alright, time for some remote code injection. CD drop table. No, I'm joking. I'm sure that it wouldn't work, but I won't even bother trying. All right. Well, okay, so we have this body data custom ID split underscore, getting the second one, member.user ID, and then you reply with components. So is that like component? Is that like a UI component that shows? I don't really know too much about this, unfortunately. I do want to learn more. Yeah, I guess this is like a custom UI component. Yes, I'm sure. Else message dot content color components. Parameterized queries. Nice. But everything runs on the front end, or do you have code that runs on the back end? I guess it'd be easy to see. I can check the network tab. What's quote? Why is quote of, oh, nice, look at that. So your quote does actually perform an API call. Through perseverance, many people win success out of what seemed destined to be certain failure. That's pretty cool. Let's get another one. From error to error, one discovers the entire truth. Wisdom begins in wonder. We never live. We are always in the expectation of living. That's deep stuff right there. Then again, you know, what else would you expect from Voltaire? The pain passes, but the beauty remains. So, is it you've? I'm assuming you've curated this list yourself, or are you pulling these from some like open API? How long have I been live for? 1 hour and 20 minutes. Okay. I think I'm close to having a solution to this problem. I just got to figure out this last little bit. And I'm not getting off yet though. I need to solve a couple of dynamic programming problems. OpenAPI with an NSFW blocker. Makes sense. But you have it behind your own endpoint though. Were you hitting the API directly? Oh, there's no history when you come back. How hard would it be for you to put the terminal history in local storage? So if I come back to your website and I start hitting the up arrow, it takes me back to the commands that I previously run. That would be cool. That probably wouldn't be too difficult to do if that's something you were interested in. Oh, okay. It's api.quotable.io. That's cool. I've never heard of quotable.io. Yeah, cookie. Cookie is not actually what I was even thinking. I was thinking just local storage. You could even just have an array, right, of the last of like the last 50 or something. Oh, is there no homepage for this? Like, so the homepage is their GitHub page, right? I'm guessing that's what this is. I've never seen that. I've never seen someone do that before. I thought there was going to be like a quotable homepage, but the... Gotcha. Yeah, fair enough. Work that you don't have time for right now. I have such a long list of features that I want to add to my word game. Some of them will probably never happen. So one thing that now that I'm getting into streaming, I want to start looking into like Twitch bots and how to automate the stream. And one of the things that I discovered that's actually really cool is you can write Python scripts or Lua, but I would use Python because that's the language I know. You can use Python scripts to like hook into all of the OBS events that are running on your local OBS instance. And so, for example, I have a couple of scenes, like my Be Right Back scene, that, like, for example, if I switch to that scene, I want to automatically mute the mic And there's plugins that I can download to do that, but I want to learn how to do it myself, because apparently you can accomplish stuff like that just by writing a little bit of Python and hooking into like OBS's internal like API and stuff like that. You've been building a passion project. If I'm all right to explain it, yeah, go right ahead. I mean, I'm just chilling. I am. Hopefully, I do want to finish this project, but I enjoy when people come into the chat and hang out. So and tell me what they're up to. So go ahead. I'll definitely read it. Okay, so I start off from at I start off 2 at I minus n zeros. Then I'm gonna continue doing the loop while the position that I'm moving to is not 0. Oh no, this is wrong. This is wrong. This does need to be a while loop. While nums2, like a normal while loop. While nums2 is not equal to 0. And so then after we perform the swap, or the move, we've got our temp number. Oh, okay, that needs to be up here. We need to store that. Int number to move, and it just starts off as being x. I have built a Twitch bot that uses a TTS fire event, so say if I say be right back or be right back, it will switch and mute mic. Yeah, that's cool. It's a good idea. I like that. So do you stream on Twitch as well? It's kind of open API project where people can make their own API. And then serve it easily and add endpoints through a dashboard. They can add data to those endpoints super easily and integrate with other APIs easily within the app using OAuth. As I heard lots of people struggling with Passport and Discord and email and password login, so I first built the package called BTOA, which sounds like binary to ASCII, but I'm assuming it's something else, for easy login with code, but then people still was struggling with it. So this has the no-code version of logins. Yeah, that's dope. They don't have to worry about PHP or SQL. All they do is choose MongoDB or SQL, put in the Mongo URI or SQL database details, and off they go to generate database structures. They can customize the design. Sweet. That's pretty cool. Do you use any of the do you use any of the like cloud platforms like GCP or AWS? So I personally like to use AWS as the backend for most of my side projects, for the sole reason that it's the one that I'm most familiar with. And so AWS has something called Cognito, and it's basically like their fully managed, fully hosted, like user management system, and you can like let people log in with you got servers in your house. Nice. That's the cheap way. I definitely spend a little bit more than on AWS per month than I really want to, but so with Cognito you can have people sign in with different identity providers, and it has like those databases you were talking about, like it just does all of that for you. You can also have people sign in with username and password too, if they don't want to connect to one of the supported backends. But it's really nice. It's really good. AWS has so much stuff that makes all my side projects way easier. But like the other part of it is also the learning experience, and building something like that from scratch, even though it would be a lot more effort and probably a lot more brain ache um, you'd definitely learn a lot doing something like that. The 2x64 core Threadrippers, total of 800 gigabytes of RAM, 1.2 petabytes of mixed SSD and HDD storage using Unraid. Damn, you got your own data center. You got your own data center in your house. That's impressive. Um, I don't know if I would ever do that, but mad respect for doing that though. Like, I just love having everything like in the cloud and being able to access all my stuff using, like AWS's dashboard. All of their services, at least, where it makes sense, they integrate pretty seamlessly with each other. I love the concept of serverless functions. Like a lot of the stuff that I do in my side projects is written with Lambda, with triggers coming from like an API gateway, like REST endpoints, or it could be timed triggers. Um, you can trigger a Lambda function for basically anything. You can trigger a Lambda function when someone performs a DNS lookup for like a domain that you have hosted using Route 53, which is Amazon's like DNS hosting system. I actually had to have my arm put into a support after putting all the hard disk drives in the array. Wait, you injured yourself doing that? I'm sorry to hear that. I hope your arm's doing better. They must have been really big and really heavy. Is your arm doing better now? I mean, as a developer, the arms and the hands, they're very important parts of the job. So that could be worrisome. Sheesh. The constant motion killed your wrist. Are you doing better now? Oh, let me just run this. This is still not right. Okay, so I need to. Since we've been chatting so much, my brain is slowly forgetting the progress that I made on this problem, which is okay. It's okay. I enjoy the chatting. Oh, it was 3 years ago. Okay, cool. Glad your arm's doing better. I think I asked this a couple of times, but have you done any have you tinkered with streaming yourself, or do you consider yourself mostly a like a viewer, in the Twitch community? I was a viewer for many years. I think I've been watching Twitch streams for over 10 years now, maybe between 5 and 10 years, and I've had this inkling to start streaming for a long time, and I'm finally doing it, so I'm happy about that. Um, couldn't do much coding if my arm was still bad. On and off when I have time, I just like playing with the Twitch API and coding stuffs. You know what? I agree. It's a lot of fun playing with stuff. Like tinkering. I feel like is some of the most fun you can have when you're a programmer. There's just like I know like most streamers, right? Most streamers, if they want to add some sort of a customization to their stream, they have to go through like a pre-built solution. So they have to either add a plugin to OBS or do something with like Stream Elements or Streamlabs, or they have to find. So it's also possible to like download like Python or Lua scripts that other people have written and just like throw it in there, and like kind of hope that it like does what you want. But since we're developers, we actually have an advantage in that if we want something like completely custom that doesn't exist yet, there's not really anything other than our own, perseverance and willpower stopping us from just going and building that. And so I really want to get into like writing custom integrations for OBS and stuff like that. Okay, hold on a sec. I need to be right back just for a minute, like 2 or 3 minutes. Okay, I'm back. You despise browsers so much that you built your own. Built your own browser? That's impressive. Did you use like Chromium or something for that? Or it's like fully from scratch? That's what I'm curious about. I don't think I would ever venture into browser building territory. Okay, let me get back to this problem. So we've got our number to move, which is x. We've got our from and our to. If we're not moving to, if we are moving to a 0, fully from scratch with your own DNSP system. I'm gonna have to look up what a DNSP system is. I know what a DNS system is. Is the P a typo or? That's pretty cool. So, like the rendering and all that, you built all of that, like parsing and rendering CSS, HTML, JavaScript. It relies on promises as well. Is it like you built it with JavaScript? Do you have a link to that? Is that on your GitHub? I'm fascinated by that, by the notion of a fully customized browser that's built from scratch. Oh, your GitHub command on your command line doesn't work right now. Maybe you just have like an old link, an old URL or something. But that's okay. I can get to it from somewhere else. Okay, this link under the sumFetch function does work. Just the GitHub function by itself isn't working right now. Gotcha. Let me look at your contributions. That's way more impressive than my contribution timeline. Oh, this is cool. Apparently you can view contributions in 3D, VR, and IRL. Look at that. There's your GitHub timeline in 3D. Did you know you could do that? Oh, you 3D printed it? That's cool. It's like a little city. Now I kind of want mine, but I need to wait to have more contributions before it'll ever be anything other than a flat landscape. Let's see. So maybe I can just print off February through May of this year. This is when I was working on Xertal, and so even though the repo is private, I have it configured so that the contributions show up anyway. Let's see what that looks like. What? That's it? I just have one skyscraper? Wait, that can't be right. How do I, maybe I have to change the, how do I change the timeline? Oh, interesting. You have a repo that's just named after you. I don't have that. I'm actually surprised I found that based on what you just said. 77% JavaScript. Total stars. Oh, you got 21k, 2.1k stars. I don't think I have any stars. Sass, JS, React, Gatsby. Yeah, React and Gatsby are two tools that I really love as well. Anytime I'm building anything on the front end, I'll use React. If I'm doing, something that Gatsby makes sense for, I'll use that. And your total commits is in there as well. Ooh. Did you set yourself a time goal for 1 million commits? That's a big milestone. Like, well, even the fact that you already have 750k is very impressive. Are you one of those people who makes lots and lots and lots of really small commits, or are all those commits like, pretty bulky in their content? I commit completely differently when I'm working on personal projects than when I'm at work. That's probably every professional developer as well. Like if I'm committing for this is a Flum float, the guava citrus one. I shouldn't be doing it. I'm telling myself right now that after I finish this, I'm not going to immediately go buy another one, at least for a while. We'll see how that goes. And your Discord, okay, so Discord is hosted in GitHub then? That's cool. 2 jobs ago, when I was working at, when I was working at Squarespace, we had the same thing. We had all of the Smoke Priv X. Cool. Well, fellow Vapor in the chat. That's pretty hype. What was I saying? Oh yeah. We had this big migration because Squarespace was using GitHub Enterprise, and then they were migrating to like fully managed GitHub from GitHub themselves, and so that was fun. Let's see. Oh, you got one of the refillable ones. I had one of those once and I didn't like it. I like the disposable ones. It is nice that it has a UI though. So that's pretty cool. And it's also nice that, you can fill it with whatever you want. But I had one. It was also by Smoke or Smoke, however you pronounce that. And it broke, so I didn't buy another one. But I just didn't like it quite as much as the disposable ones. I'm sure it's better for the environment though, since you just have to buy the refills. Need to get a new keyboard. So, where are you based, if you don't mind me asking? I'm in San Francisco, and I'm aware of the Discord office around here. Is that where you work, or are you remote? Or do you work in another office in another city? Yeah, that would be annoying. Oh, cool. Okay, you're local. Sweet. Yeah, I was working out of the Google office on Market Street, and that's pretty close to where I live. but now I'm not. So, but I am looking. So for my next job, ideally, I can find something that if office like in office work is required, I can just get there pretty quick. So something in San Francisco. I'm not looking to relocate. Yeah, that's something we could do. I would be open to something like that. We could nerd out about software. Oh man, am I actually gonna finish this problem? I've just been talking to you. Okay. Boba also obviously a very good call. Very good call on the Boba. So, if the number that I'm moving to is a 0, then I perform the swap. Okay, so that means that I was right. This is just do while. Because I already know it's a 0, because otherwise I would have continued. So I get my from and my to. I still need my int number to move, and that's going to be nums from. So nums2 equals the number to move. Nums from is 0. And then, okay, so this is definitely right. Then the new number to move is the temp number that we just grabbed. Yeah, go for it. I already whispered you mine, so feel free to send me an email or whisper me your email. Okay, so I'm pretty sure these 4 lines of code are right. Now we just need to update the pointers. So we've got our to and our from. From is the new to. So from equals to. But then the new to. So let's make this. Let's make this. We have to save our from for a second. I can just reuse the same temp variable that I already had. From equals to. And then the new to is going to be. Oh, okay, so the new to is, let me get rid of these 2 lines of code that are wrong. Okay, so the new to is this, it's going to be 2 minus I think it's this, so maybe we don't need this line of code. Okay, let's see what this does. Okay, let's step through and at least see what's happening. Nerding out about coding over Boba sounds totally worth it. Yeah, I agree. I'm gonna run this in the debugger and let me set a breakpoint. I like how Premium LeetCode gives you the debugger, and I'm trying to get into using it more. So let's put the breakpoint here, I guess. No, I kind of want the breakpoint after that line executes. So let me just do int dummy equals 0, and I'll just set the breakpoint right there. And debug. Oh. But yeah, thanks for dropping in here and chilling. If you think you'd come back one day, I wouldn't mind it if you hit the follow button, but no pressure. I think right now my daily follower count is ambitious, setting it at 5. I might start doing 2 instead. Oh, you're gonna head out for a little. Gotta put the nightmare kid in bed. Scream. Oh, okay. I want bedtime story for ages. It was fun talking. Yeah, it was great. It was great. Yeah, we have each other's emails. Hopefully, yeah. Thank you. Appreciate it. I also wanted to make sure my alerts were working, so I had multiple reasons I was asking you to do that. Cool. Yeah. Thanks for following. Thanks for stopping in. Hopefully, yeah. I mean, we'll chat again. We've got each other's emails, and I'm gonna be doing this stream every day for a while. Do you want to go by Izzy? Should I refer to you as Izzy? Should I call you Ayu? Should I call you River? Seems like there's a lot of options. What would you prefer to be called? Izzy? I'll just call you Izzy since that's your Twitch username. Okay, cool. All right, well, good luck with the kiddo, and again, thanks for stopping by and thanks for the follow. Okay. All right, so looking at the scene 0 count, let's just make sure that's right. That's probably going to be right. So the input that we're dealing with is this one. I gotta quit the debugger. Let's just make sure we're producing the correct scene 0 count. I knew I was going to have to debug this problem, but I think now I'm actually at a point where it makes sense to do so. So the scene 0 count, well, okay, so the answer should be 131200. That's what we should get as the answer. But then the scene 0 count should be 11222, and I think that's what it was. So let's go back to the debugger and debug again. Okay, so we had our first iteration of the while loop. From was 2 and 2 was 0. Oh, you know what? No. I should debug right here at the start of the while loop, actually. Okay, so we're at the first part of the while loop. What are from and to, importantly? So from is 4 and 2 is 2. So that's correct. We do want the 12 to move there. So I doesn't matter. We've got our nums, which is that. Okay, so if we step over these lines, what do we end up with? We go from 010312 to 011230. So that's correct. That's absolutely right. So let's see what happens after we update the from and the to pointer. Okay, so the new from is 2. Oh, that's not right. The new from should have been 3. Oh, no, it is right. It is right, because what we're trying to do right now is we moved the 12 to position 0. Oh, okay. So because we moved the 12 to an empty slot, we actually want to stop the loop. So let me implement that real quick. So if nums at so because we moved the 12 to an empty slot, we don't have another number to move. Oh, wait a minute. Back to the debugger. We might have been right there, actually. So we did all those. The number to move is 0. Okay, so I think what might work is changing this this while condition to check that the number to move is not 0. So let's see what happens if I run the code with that. Okay, so we're still crashing, but that should at least be more correct than it was before. So 0, 1, 0, 3, 12 is the nums. And so when we step over these 4 lines of code, now we have 0, 1, 12, 3, 0. We have our from is, okay, let's update the from and the to pointers. Okay, so we have number to move being 0. So because number to move is 0, it's going to break out of the while loop. From is 2 and 2 is 0. Okay, but we're going to ignore that from and the 2 because we're about to break out of the while loop. So a step over that, what happens? We come back up to the top, and then we're now I is 3, so we're looking at this 3 right here, and we're trying to see where it moves to. We should discover that it needs to move to where the 1 is. So we got our from and our to. From is 3 and 2 is 1, which is correct because we should be moving that there. Okay, so after we execute these 4 lines of code, okay, it worked. So the 3 was moved up to where the 1 was, and our number to move is 1. So we update the from and the to. So now the from is 1 and the to is 0. The number to move is 1. So this should bring us right back around into the loop again. If I step over these lines of code. Okay, so as of right now, wait a minute. Oh, we only want to update the from number. We only want to update the from number the first time, because we just got rid of the 3 that was here. Let's see. Okay, that's easy to do. Let me stop the debugger and just fix that part of the code. So we only actually, because every time we like start going through this loop, it's only when we're like bumping other non-zero numbers forward. So because of that, we just have to update the from number to be 0 once up here. Okay, so let's debug it again now with that. And So we start off with okay, so we start off with 0, 1, 0, 3, 0. When I step over these lines, the 12 will end up in the right place, and we will exit out of the while loop because we've moved 12 all the way where it needs to go, and no other numbers need to be bumped. So then we come back in. Now we're looking at the 3, which needs to move to where the 1 is. So that works, that happens. We update the from and the to again, and our number to move is now 1. So we come back into the loop, we step over these lines, and so as of right now, if you look at the code, we actually have the correct answer. So it's supposed to be 1, 3, 12, 0, 0. But what happens next? So I think the only thing we're missing now is let's keep stepping over and see what happens. So the from becomes 0, the to becomes -1. Okay. So 2 becomes -1, and that means that we need an extra condition in our while loop that we terminate it if 2 is less than 0. So we do while number to move is not 0 and 2 is greater than or equal to 0. Okay. So let's debug one more time. Well, I don't know if it's one more time, but and let's just keep hitting play while everything happens. So we end up with okay, that's not right. What happened there? So we get the 0, 1, 12. We get the 0, 3, 12. So now if I step over, okay, from equals 2, 2 equals, okay, so 2 is now -1. So we break out of the while loop. It's going to take us back up here. So right now the answer is right. It is supposed to be 1, 3, 12, 0, 0. But let's see what happens next. So I is 3. So now I is 2. Okay, so we passed both of those conditions. Do we... What? Hold on, let's step over... If the number we're moving to, we only... Okay, I think we can break out of the while loop if the number at 2 Hold on. I shouldn't have exited debugging there until I knew exactly what the problem was. Let me go back into debugging, skip all that stuff again. So we get that 2 becomes -1. That's not greater than or equal to 0, so we come back out, and now we go to I equals 2, so it's looking at the 12. But the thing is, we've already finished. Like 12 is already done. But how do I detect that in the code is the question. We're already done now. We've already produced the answer. It's supposed to be 131200. But we're still coming back through the while loop from the end to the beginning, and we moved over the numbers, and now we get to 12. And the scene zeros is 2, so it thinks that it needs to move over 2, but it doesn't. Oh, maybe, okay, as I think I understand. As we're moving the numbers over, we specify that it doesn't need to move anymore. Yeah, that's what it is. I think that'll work. So we grab our number to move, set it to 0, and then we come through here, we perform the swap, and then we specify that scene 0 count of 2 equals 0. And now let's debug again. Oh, wait. Do we need to do that here? This problem is not going as well as I had thought. Okay, so we get there, we step over this. We get that 2 is maybe, okay, it's where we moved from. Yeah, it's where we moved from. So this is scene 0 count is not actually a good name for this array anymore. It should be called like distance to move. Okay, make that an int. Okay. All right, so Okay. So I had to rework the distance to move array a little bit, since it was the scene zeros array. So now what we're doing is when we first pre-process the input, for every number that is not a zero, we're putting in the distance to move array, how far it needs to move, and we're still figuring that out the same way, which is the number of zeros that we've seen so far. And so every time we come through the loop, if we encounter a number that doesn't need to move at all, so if it's zero, that actually means that we're done. Otherwise, we skip zeros and we do our to and from, and then importantly, down here after we do the move, we mark that we now don't need to move in the from tile anymore. Because since we just moved it, the distance that needs to move now is 0. Okay, so let's get some more test cases here. I should have used the example test cases, and then let's use 0, 1, 0. Okay. All right, so let's take a look at this test case 0, 1, 0. Obviously it's supposed to be 1, 0, 0. Our code is producing 0, 1, 0. So let's go through the debugger with that. Okay, so we also, first we want to check here, here, let's do it this way. So at the top of this for loop, we grab the x and the distance, like this. And we only want to break if x is not equal to 0 and the distance is 0. Okay, so that passes that test case. I've been working on this problem for a while, so I'm kind of in just like kind of finish it mode, hopefully. Okay. So we get accepted on that problem. It's a little tricky if you try to do what the description suggests as the follow-up. Follow-up is minimizing the number of operations done. And when you minimize the number of operations done, you're effectively saying, it's effectively asking you to solve it in linear time as opposed to anything higher than that. So a brute force solution to this problem could be solved in n squared time. But because of how we've implemented it in linear time, which is supported by the runtime we got in our last submission. It's faster than 92%. So we got that. Let's delete these comments. And the only other thing is our memory is not good. So if you look at the submissions, our memory usage is 19 megabytes, which is less than only 6% of other C++ submissions, which is not ideal. And I think the only reason that's happening is because we're using this secondary distance to move array. So even though we do have the optimal runtime, it seems there's probably a way to implement this such that you don't need the distance to move array. So we're using the distance to move array to keep track of how far all the non-zero numbers need to move. And so is there a way that we can do that as we go? Okay, well, I kind of want to move on from this problem, so under other circumstances, I might sit here and stare at it and try to figure that part out. But since we got the optimal runtime, which is linear, I'm going to go ahead and look at the solution for this. Solution. The question comes under a broad category of array transformation. The category is the meat of tech interviews, mostly because arrays are such a simple and easy to use data structure, blah, 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 blah. Two requirements are move all the zeros to the end. Yeah, we got that. Non-zero elements retain the order. It's good to realize here that both the requirements are mutually exclusive. You can solve the subproblems and then combine them. Interesting. I think I understand what they mean by that. So you could just iterate through the whole array. If you were to make, okay, yeah. So you got the space suboptimal solution, which is also what mine is. You could create a new array that just stores the non-zero elements, and then once you have that, you basically just copy over the non-zero elements of the input array as you iterate over them. And then you can compare the lengths of those two arrays, and you'll know how many zeros to add to the end of the array that you just made. So count the number of zeros. Make all yeah. So that's exactly this. You do get the time complexity of n and the space complexity of n because you're creating the answer subarray. Approach 2 is space optimal but operation suboptimal. So the approach works the same way as above. It first fulfills one requirement and then another. Hold on a sec. It does the catch. It does so in a clever way. So the two-pointer approach. The fast pointer, which is denoted cur, does the job of processing new elements. If the newly found element is not a zero, we record it just after the... Right. Okay. What's the optimal solution? Because I'm sure optimal is, time complexity O of n, space complexity O of 1. So total number of operations is suboptimal. For example, the array which has as many write operations. We could have instead written just once. How? By fixing the non-zero elements. By only fixing, so this is kind of what my solution is doing. We're just fixing all of the non-zero elements. The optimal approach, again, is a subtle extension. A simple realization is if the current element is non-zero, its correct position can at best be its current position or a position earlier. Okay, so we are doing that. If it's the latter one, the current position will eventually be occupied by a non-zero or a zero, which lies at an index greater. We fill the current position by 0 right away, because we don't need to come back here. So that's what our solution is doing. After we make sure that like this cell needs to be processed, we just overwrite the current value to be 0. In other words, the code will maintain the following invariant. All the elements before the slow pointer are non-zeros. All the elements between the current and slow pointers are zeros. Oh wow. Look at how short the optimal solution is. So mine also has a similar invariant. So my invariant is that as we're iterating backwards over the array, the numbers from I through the end are final. So they could be 0 or they could be non-zero. But if they're zeros, they're final. If they're non-zeros, they're final. So that means that after we finish processing the current element, we never have to go past it again to update anything else. I do like how the solution specifies what their invariant is. So then let's have a look. So let's have a look at how it works. Therefore, when we encounter a non-zero element, we need to swap elements pointed by the current and the slow pointer, then advance both pointers. If it's a 0 element, we just advance the current pointer. With this invariant in place, it's easy to see that the algorithm will work. So if the, so, okay, so that, like they said, they've got 2 pointers. We've got the last non-zero found at. They start that off at 0. And then they've got the current, which they start off at 0. Current just needs to be less than nums.size and current plus plus. So current is kind of like my I. It's just going through the array, except they're going through the array forwards. Now, if the current number is not 0, then we swap it with the position that we found the last 0, and then we also, in that case, we increment the last non-zero found at. Man, that's crazy that works, isn't it? That's such a short solution. So last non-zero found at is probably not the best variable name for this. They start that off at the beginning. So basically both pointers start off at the beginning of the array. And if the number there is not 0, it swaps with itself, so nothing happens. And then they move the last non-zero found at pointer up. Then they go to the second element. If it is not a 0, oh, I see. So the last non-zero found at pointer only increments when you hit a non-zero element. That makes sense. That's tricky. And that solution is honestly kind of genius. Let's see, does anyone do anything similar to what I did? Let's look at some of the other solutions that people posted here. Doesn't look like it. Looks like I came up with something different from everyone else. It's not as memory efficient, but it is time efficient. So, okay, so I'm gonna move on from that problem. That was problem 283, move zeros. We ended up getting a optimal solution time-wise, but not memory-wise. Okay, so let's leave that one and move on to probably the last problem of the stream. And it's not going to be any of those. Oh, what is this? You were given an array strings product and a string search word. Design a system that suggests at most 3 product names from products after each character of search word is typed. Oh, this is a try. Suggested products should have a common prefix. Yeah, this is a try problem. Have I solved this one before? No, I have not. Let me just see if this one's on my list. Okay, it is. So that one's on my list, so I'll probably do that one tomorrow. What I really want to do right now is look at a dynamic programming problem. So we're making our way through the dynamic programming study guide that LeetCode provides. So right now, technically I'm on day 3, and we're going to look at this problem right here, house robber number 2. So start now. I'll paste the link to the LeetCode problem in the chat. And just jump right into it. So you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All the houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected, and it will automatically contact the police if 2 adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so yesterday we solved version 1 of this problem. And it looks like the only difference that they added was that in this problem, the houses are arranged in a circle. So how does that change the solution? Because I feel like for the most part, this is probably going to be the same. So let's take this input, for example. 1, 2, 3, 1. The output is 4, and the reason the output is 4 is because you would rob the first house and the third house. So the solution that I wrote yesterday, we came up with two different DP arrays. We had DP1 of I is max money when for houses houses 0 to I and definitely robbing I. And then we had another DP array, DP2, which is parallel, is similar, but it's the max money for the exact same houses, 0 through I, and definitely not robbing house I. And so then we built a for loop that filled those two arrays with answers, and once we finished doing that, let me just get this in here. N is just going to be the size of the input. Once we got to the end, the answer was just the max of either robbing the last house, DP1 of n minus 1, or so it's robbing the last house or not robbing the last house. And then I have a decent recollection of how we just made a simple for loop that built both of these arrays. So the twist now is that the first house and the last house are connected. So if the first house and the last house are connected, with my solution to the problem for yesterday, it's possible that you robbed the first and the last house, but now you cannot rob the first and the last house. You have to rob one or the other. And so that's the twist that they add to this problem. Okay, let's think here. This is going to be max money from houses. Max money from houses. So what I'm wondering is, if I build those two DP arrays the exact same way as I did yesterday, can I still use those to get a solution? So the problem is, this array right here, DP1, specifies that you're robbing the ith house. Okay, it's tricky. Let's uncover the first hint. Since house 1 and house n are adjacent, they cannot be robbed together. Therefore, the problem becomes to rob either house 1 through house n minus 1 or house 2 through n, depending on which choice offers more money. Yeah, okay. I was hoping the hints wouldn't just immediately give it away, but that's just the answer. So basically, we just do it twice. Like what we did yesterday, we just do that exact same thing twice. We do it once for 0 to n minus 2, and we do it again for 1 to n minus 1. So we're going to have an answer, and since we're maximizing, we'll start this off at -1, and then at the bottom we're going to return the answer. And so what I'm going to do is I'm going to create my two vectors, dp1 and it's going to be, instead of it being size n, it's size n minus 1, because we're not robbing. Basically, one house on either side we just don't take into account. So we got dp2, and let's see if I can remember how I did this yesterday for the house robber problem. So for int I equals 0, I is less than n plus plus I. We do also have some base cases. So dp1 of 0 means we robbed the first house, so it's going to be nums of 0. And then dp2 of 0 means we don't rob the first house, so it's 0. Then when we update dp1 of I, so I starts off at 1, and it goes to n minus 1. So robbing house I means that it's num sub I plus the best we can do by not robbing house I minus 1. And then dp2 of I, this is the part of the problem yesterday that took me a while to figure out, but it's actually the best that we can do by either robbing the previous house or the one before that, because no, it's the best you can do either from robbing the previous house or not robbing it. So it's the max of dp1 sub I minus 1 and dp2 of I minus 1. And then once those loops are done, the answer is going to be the max of, we can just create the answer variable down there. So the answer is going to be the max of either robbing the last house or not robbing it. So dp1 of n minus 2 and dp2 of n minus 2. And then now we do that same thing again, except now we're starting at house 1, which means this is still the same. This is now I plus 1. And then the answer is the max of the current answer, or the solution to this subproblem of ignoring the first house. Hold on a sec. This is, these are not initialized correctly. So if we just get 0, okay, so for this test case where they just give you 0, that means there's one house on the street, so in a circular fashion it's connected to itself. Does that mean you can rob it? So this might be as simple as if n equals 1, we return, well, only adjacent houses have the security system. So I think that if there's only one house on the street, you can rob it. Okay, there we go. So we get that one. 8 milliseconds, 8 megabytes of memory. The runtime, let's submit a few more times to see what the range of the runtimes is. Okay, yeah, it's one of those ones where the code runs so fast that LeetCode system can't measure it very well. So I'm getting runtimes ranging from 0 milliseconds to 8. But whenever it hits that 0, it is faster than 100% of submissions. So this is the optimal runtime. This is O of n. Okay, so that's good. So we do solve that problem. Small twist on the previous one. So if we go to the dynamic programming study plan, let me just have a quick look at what problem 740 delete and earn is. Oh, I didn't see this follow come in. Nizuma number 94, thanks for following 15 minutes ago. Appreciate that. Not sure if you're still in the chat, but if you are, welcome. Welcome to the stream. Hope that you're finding this useful, or at the very least entertaining when I keep getting wrong answers. Okay, so let's look at problem 740, delete and earn. You're given an integer array nums. You want to maximize the number of points you get by performing the following operation any number of times. Pick any nums I and delete it to earn nums I points. Afterwards, you must delete every element equal to nums I minus 1 and every element equal to nums I plus 1. So let's look at the first example. So if the input is 3, 4, 2, you can perform the following operations. So the output is 6. Okay, the output is 6 because you can delete the 4. If you delete the 4, You also have to delete the 3, but you get 4 points. And then after that, you can delete the 2 to get 2 more points, so you get 6. And if we look at example 2, we've got 2, 2, 3, 3, 3, 4. The answer is 9, and so you can perform the following operations. Delete a 3 to earn 3 points. All the 2s and 4s are deleted. And then you can delete a 3 again, and then you can delete a 3 again to earn 3 more points. And so that's where you get your 9 from. So the constraints are 2 times 10 to the 4. So I think because of that, because of the constraints, I don't think this is a linear runtime. I think that this is an n-squared runtime. And what we need to do now is represent, we're going to represent this problem as a dynamic programming problem. So let's get our nums.size again. Just store it in n. What's the, let's see, the range of the numbers is between 1 and 10,000. So do we pre-process the input? Do we pre-process the input and store like a frequency table, right? So we could have like 2 elements of, we could say there's 2 2s, there's 3 3s, and there's 1 4. Okay, so I've solved problems similar to this one before, but I'm not sure if I remember exactly what the proper approach is for this. So ideally we can get to the point where, let's just assume that we have like a vector of int dp of size n. Let's just assume that we have that. And if we can get to the point where the answer is just dp of n minus 1, the last element, then we're in a good place. But we still have to specify what dp of I means. Maybe this is not a dp over the elements of the input. This might be a dp over the range of numbers, right? So since the range of numbers is 10,000, maybe you're not dping over the input array, but you're dping over those numbers. You're saying like, yeah, okay, I think that's what it is. That makes sense. So for example, like dp of I means dp of I is something like max points I'm just like kind of brainstorming out loud here, but dp of I would be something like the max points you can get if you delete the integer I from nums. So if you delete I from nums, then you get I points, but you'll also have to delete all of the I minus 1s and all of the I plus 1s. So if we delete dp of I, then dp of I minus 1 is kind of like is zeroed out, right? So that's like kind of the high level idea. That's probably not quite how it's implemented. And then dp of I plus 1 is also zeroed out. So we might be able to structure this similar to the house robber problem, where we have two DP arrays. One of them means DP of I is deleting I from the numbers. And then the second one, the second DP array represents that we don't delete I from the numbers. That's kind of what I'm thinking right now. And so if we were to do it that way, then we'd have like dp of I equals I plus, okay, so let's delete this comment, let's just say, while I'm thinking about this, let's just assume we're going to do it with two DP arrays. So you'd have dp2 is the max points if don't delete I. Is that right? And so then dp1 of I would be, dp1 of I means you're deleting I from the numbers. If you delete I from the numbers, you get I points. Also, let's do this because it's going to be necessary. So n is going to be the length of the numbers input array. We'll have a second variable m, which is going to be the maximum integer that you could get. And so that's going to be 10,000. Yeah. So you can get any of the numbers in the input are in the range 1 to 10,000. So we'll have that. M is 10,000. And so then when we create our DP arrays, it's going to look like this. And it's going to be m plus 1. And the only reason it's m plus 1 is because we want to be able to put, I think for readability, we want to be able to just reference into the DP array at index 10,000 to represent the integer 10,000. And then dp2 will be the same. Keep in mind, this is all still brainstorm. I am not sure yet if this is going to work. But I do have a good feeling about it though. So let's see. So now that we have that, let's think about this. So dp1 of I means we're the max points if we delete I from nums. And so if we delete I from nums, then we don't get any points for I minus 1s, and we don't get any points for I minus 2s. Or sorry, I minus 1 and I plus 1. I might take a little bathroom break here in a sec, and also use that time to think about this. How long have I been live? 2 hours and 49 minutes. This will definitely be the last problem. I'm going to try to get to a solution though, before I end the stream. So the other thing that's useful to know, so this is important. If you delete, let's say that you delete 3, right? You delete 3, so you get 3 points. You now don't get any points for any 2s, and you don't get any points for any 4s. However, you do get points for all the rest of the threes in the input. And that's kind of, they kind of illustrate that here in this test case. I don't know if you can see it. Yeah, there we go. So in this test case, the most optimal thing to do is delete a 3. You immediately get 3 points, but you then don't get any points for any of the 2s or any of the 4s, because those are -1 and +1 to the one you deleted. But really, what's happening is as soon as you delete a 3, you actually get points for all the 3s automatically. Like, you don't have to consider those extra moves, mostly because the question really has nothing to do with the max number of moves that you make or the minimum number of moves. Like, you don't have to count moves at all. All you're doing is counting the max number of points. So as soon as you delete any number from the input, all the instances of that number you get points for. So because of that, I think we probably actually do want to create a table that just lists it just lists the amount of each number in the input. So let's do that. We can create an unordered map for that. So we'll create an unordered map of type int, and we'll call this freq, which means the frequency table. And let's just populate it real quick with the information. So for int x in nums, plus frequency of x. And then let's just make sure that that worked. For auto iter equals frequency.begin. I'm just iterating through the frequency table now. Iter is not equal to frequency.end. I think this will work. Plus iter, and then we can just log to the console what we get. So we get iter first, and then space. We'll just put like an arrow. Look at that nice little arrow, and then iter.second, and then a new line. So if we run this, so this line of code is not right. Let's get rid of that. Let's just return -1 for now, because we need the code to compile. So if we run this, oh, this needs to be an arrow. Okay, so that does work. So we, for 3, 4, 2, we calculate that there's one. Let's get the other test case as well. So for the second test case, we get that there's a 4, there's 3 3s, and there's 2 2s. And so I think having that lookup table created that way is going to be useful for solving this problem. It also means that when we're DPing over this number, this 10,000 possible numbers, we can check to see if it actually matters, if it actually exists in the input at all, just by seeing if it exists in the frequency table. So I'll comment that out, and I think that's good progress. And okay, I think we're on the way now to a solution. I'm gonna take a quick bathroom break and fill my water, and then I'll come back and finish this problem, and then that's gonna be the end of the stream. So be right back. Okay, I'm back and ready to hopefully knock out this problem. So, we've got our frequency table. Let's think about this. So if we delete I, integer I, oh, I got a smudge on my glasses. Rip. Just try to clean those up a little bit. So if I delete I, then I get points. Basically my total points is increased. So like dp1 sub I is equal to the so it's going to be the frequency. Well, let me just add this as a comment. The frequency of I times I, right? So let's say that there's 3 9s and I decide to delete 9 from the input. Then I get 27 points. I get 27 points. But when I delete 9, I cannot have any points for any of the 8s, and I cannot have any points for any of the 10s. So maybe this should be reworded here. Max points if max points if receiving points from I, and then this one is max points if not receiving points from I. And I think as we're calculating these arrays, am I just keeping track of the answer as I go? Like this, answer equals -1, return answer. So if we do it this way, dp of I would be the frequency of, it would be that plus dp2 of I minus 1 plus dp2 of I plus 1. Now this is already problematic because this is forcing us to both look backwards in the dp2 array and look forward in the dp2 array. So this might not work. But let's just see how would we do this? dp2 of I dp2 of I means we're not receiving points from I, so we can receive points from I minus 1 . I don't think I'm structuring this problem quite right. Oh, wait. Yeah. This is wrong. Let's think about it this way. Let's think about it in terms of just going through this list of integers once. So we start I off, let's call it n, so that we understand that it's not really representing an index. So we have n starting off at 1, n is less than or equal to m, and then plus I, plus n. So n is one of the integers that could be in nums. One or more times. That's what n is. And then I think we're gonna end up returning it might end up, I'm not 100% sure, but it might end up being the max of dp1 m and dp2 m, where let's change this again, this part. We don't need this comment anymore because that part of the code works. dp1 of I is the max. We want to structure it so that we're talking about like 0 to I, right? And it's going to be, let's change it to n so it matches our code. Max points for 0 to n when receiving points from n, and then dp2 is the opposite. dp2 of n is the max points for 0 to n when not receiving points for n. Okay, so I think this could work now. So dp1 of n, let's have base cases. So dp1 of 1, so the 0th index of both of these vectors just doesn't matter. We're ignoring it completely for this problem. dp1 of 1 means we're receiving points from it, so it's just the frequency of 1. Is that going to return 0 if there's no 1 in the input? We can find out really easily. Frequency of 1. Yeah. That works as expected. And then dp2, this part of the problem I think is actually really similar to the house robber, is 0, which means we're not receiving points for the integer 1. Okay, so dp1 of n then, so now we start this off at 2. And dp1 of n means we're receiving points for it, so we don't receive points for the previous one. So if we receive points for it, then it's going to be n times the frequency of n plus the max amount of points we got if we did not use the previous number. So dp2 of n minus 1. Then dp2 of n is the max amount from using the previous. Okay, so I think this is actually really similar to house robber, because for dp2 we can either receive points from the previous number or we don't, and we want to find the maximum of those two possibilities. So we take dp1 of n minus 1, which means we did receive points for the previous number, and then we also have dp2 of n minus 1, meaning we did not receive points for the previous number. Okay, so that produces the correct answer for those test cases. Let's try to create a few more. What if we have like 0? What if we just have 1? Let's just like I don't know, just do something random. I don't even know, bro. I don't know how to write a good test case for this. Let's just see what happens if we run it on those test cases. Oh, okay, it can't be 1, it can't be 0. So we could have something like that. Let's try something like this. Okay, so we produced the right answer for the test cases that they gave us and the few that I just made. So let's venture and hit the submit button. And we get it. We get it. Let's submit a few more times to get more run times. Interesting. Okay, so we get the nice green label, we get accepted, but it does seem like our runtime is significantly slower than other C++ submissions, and also using more memory than most C++ submissions. So the memory is not too surprising because we are creating this frequency table. Along with 2 DP arrays. And so what we discovered with the house robber problem is if right now our DP logic only looks back by 1, it looks at the previous and it looks only at the previous. But you can represent this solution in a way that it can be coded with a single DP array, except that you have to be able to look back 2. You have to be able to look back at n-1 and n-2. And then you structure your DP array a little differently. So yeah. So if you want to do this with 1 DP array, then your DP of n is the max points for 0 to n. And then it doesn't matter whether you so your DP of n is the max points for 0 to n, and you receive points for n, and you when receiving points for n, and then you don't need a DP2 because if you structure it so that you can look back 2, which means you have to have more base cases, what you end up getting is that DP of n is it's going to be the max of the frequency of n times n oh no it's yeah this is right. It's the frequency of n times n, so that's your points, plus whatever the max is of dp of n-2 and n-3. Something like that. So you set it up that way, and then once you have that, your answer is the max of like the last couple of elements of that DP array. So it's like the max of DP of m, DP of m-1. Yeah, those two. Yeah, that's it. And so you could restructure the problem this way. I'm pretty sure that's basically right. Something like that, where you don't need 2 DP arrays. But we did it this way and we got accepted, but it's a little bit slower than I had expected. So what I'm gonna do now is try to understand why. It might be that the test cases are pretty small, and simply doing this extra loop where we calculate the frequency table is causing us to lose a lot of, causing us to use a lot more runtime. But instead of speculating, let's just take a quick look at what the solution is supposed to be. So you've got your excellent, okay, so let's look at the solution, the overview. It's an excellent example of why you want to read the problem description carefully. We can make a substantial optimization by noticing that the order of nums is irrelevant. Yeah, we did discover that. At any operation, we pick up a number, we delete all the occurrences. That means if x occurs multiple times in nums, we take one. We may as well take all of them, right? So our solution does do that. Before we start, we can simplify nums by collecting all the duplicate numbers together. As an example, nums can be represented as a hash map with numbers as keys, mapping to the thing. Yeah, so we did do that. Furthermore, since we are only really concerned about how many points each number can give us, we can multiply the keys and values to represent how many points taking the key will give us. There's no way that makes it that much faster. In the first approach of the article, we will talk about an algorithm that solves this problem in detail. In the second approach, we will implement the algorithm a slightly more efficient way. That's probably what I want to look at there, is the second approach. But it's interesting. It's interesting what they did. So let's just do that real quick. And for some reason, I'm not confident that that this is going to help significantly. But what we can do is, instead of just having the frequency, we can have like the actual value. So we just take frequency and increase it by x. And if we do it that way, then we don't have to do these multiplications here. Actually, even faster than that is, wait, is it faster? Okay. Okay, I'm actually just gonna go ahead and look at the approach 2. So for approach 1, they came up with a space complexity of n plus k and a time complexity of n plus k, and k the maximum. Okay, so maybe that's the optimization that they wanted me to make, but right now I'm just assuming that all of the integers from like 1 to 10,000 are like, you know, since it's possible for them to be in the input, I'm just setting the largest number that I actually even look at to that. This could actually be the max of, let's see, there's definitely a way to create a max quick, oh wait, is it just max underscore element, like this, star max element of nums dot begin and nums dot end. So that's another way that we can do a little bit less work. Let's make sure that that's right though. So cout m. So instead of considering all the numbers from 1 to 10,000, we can figure out what the largest number is, and we can just use that. Yeah, so that works. Let's submit that again and see if that made a difference. Oh, okay, interesting. So by doing that optimization, that I don't know if I would bother to do it in a competitive situation like a contest, but by figuring out what the maximum integer is that we actually have to worry about, we significantly increased the speed and the memory efficiency of our program, which probably means that the test cases are kind of small. Or at least that there's a bunch of small test cases. Okay, so now that we got a better runtime, we got the bottom-up dynamic programming, and let's see how they did it. Approach 3, space optimized bottom-up programming. So that's just going to yeah, they're just keeping track of the 2 back and the 1 back. And so I'm trying to understand, how do they get around having to look back 3? So so this is the recurrence relation for the DP. So the max points that you can get for a specific number is the max points you can get for the previous number it's either the max of that or the max points you can get for the previous number minus 2 plus the number. So you can get around using the 2 DP arrays by just looking back 2, which I discovered that yesterday, but I'm still trying to understand. I'm trying to convince myself why this is right. I mean, obviously it's right, but I just want to be able to explain to myself why that's the case. It does kind of make sense, right? Oh, I get it. I think I understand why. Because if you just take the max points for the previous number, then you're not including the points that you would get for the current number. So either you use the max that you discovered from the previous number, and you don't take points for the current number, or you use the max that you got for 2 numbers ago, but you take points for the current number, and then you maximize both of those, and that's the max points that you get for the number. So that makes sense. The last 2 or 3 times I've had a DP problem like this, I've done the 2 DP arrays separately, where one means you're receiving points for n, and the other one means you're not. Which does work. It does produce an optimal, efficient answer, but it's actually not necessary. So hopefully, it's not going to be today, but hopefully next time I get a problem similar to this, I plan on trying to implement it this way instead. Just so that I have that, just so that I have that in my back pocket, because it is a little faster to write. And it's not significantly more difficult to reason about either. Like this, if I look at this for long enough, this line of code makes sense to me. Okay, so approach 4. Let's just have a look at this. Iterate over elements. Okay, so that's n log n instead of n plus k. Oh, so are they doing a binary search? How are they doing? So populate points, we iterate through nums once, which costs linear time. Next, we take all the keys of points and sort them to create elements. In the worst case, when nums only contains unique elements, there will be n keys, in which case the cost of the sort is n log n. Lastly, we iterate through the elements. That makes sense. Wait, what's the point of sorting it? Does sorting it matter? So pre-compute how many points we gain from taking an element. So this part makes sense. And then we sort that by the keys. Ah, yeah, you sort it by the keys. Okay. Yeah, you need to sort it by the keys because it still matters, like the whole not being able to use I minus one or not being able to use I plus one if you're using I. So the keys do have to be in order. Okay, so last but not least, further thoughts. Below is some additional discussion on how the algorithms we can create can be optimized to create a fully optimized approach. The previous solutions would be sufficient in an interview setting. This is just bonus content. Okay. So approach 3 has a complexity of n plus k. Approach 4 has a time complexity of n times log n. What do they get? Oh, okay. So they combine the two approaches and they end up with big O of n plus the minimum of k and n log n. And so all they do is they have all they do is they check to see which of those two produces less operations. So if the max number is less than n times okay, alright, yeah, I guess if you're really, counting the CPU cycles and you want to make sure that you're as efficient as you can possibly be, you could do it that way. That makes sense. And someone very astutely pointed out here in the comments that this is a slight modification of House Robber, which is fair. Can we call this House Robber 4? Okay, so that's it for that problem. That's the last problem I'm doing today. So I did complete the day 3 section of the dynamic programming study plan, and let me go take a look at everything I did. Okay, yeah. So the problems I solved today were find all numbers disappeared in an array, move zeros. Move zeros was tricky. That was I solved it using a cycle sort-esque solution. Then House Robber 2, which was a small modification on House Robber from yesterday, and then delete and earn, which is also pretty similar to House Robber as well. Okay, so that's it for the stream. Anyone watching, anyone who stuck around, thank you. 2 follows today, 2 new followers. Thank you for that. Really appreciate it. I'll be streaming again tomorrow, doing more LeetCode. There's 2 LeetCode contests tomorrow that I also, I at the very least will participate in the evening one. There's a morning one that might be a little bit too early, so I'm not sure if I'm gonna participate in that one. But yeah, that's gonna be it. Thank you very much for watching, and I'll see you next time. And let's go over to the end stream screen. Peace.